welcome to the 14 Cardano Developers Office Hours. My name is Darlisa, and I will be your host today. So today's topic will be cover the IBC, the Interblockchain Communication Protocol project that's going to be presented by Fabian Bormann and Giovanni Gargiulo from Cardano Foundation. In this session, we'll cover an overview of the repository architecture, the current state of the development, and a live demo showing how to send a message from the Cosmos side to a local Cardano DevNet. And just a quick reminder, so as Fabian mentioned previously, you have changed the format of these calls. So this session is going to be divided in two parts. So the first 30 minutes will feature the IBC presentation. This part is going to be recorded, and for those who can to make a live, of course. And then the last 30 minutes will be for general discussion that won't be recorded, and then you can freely ask your questions. And just one last thing. So we encourage you to submit any questions that you might have in advance for the best experience through the link that you'll share there in the chat in a few minutes. So Fabian, the stage is all yours. Thank you.
Thank you, Darlisa. Today we want to give some insights in the project we're currently working on. It's the Cosmos IBC bridge for Cardano. What does it mean? So just as a high-level overview, you're maybe familiar with operating bridges or with how a bridge should work, and often it's a centralized way to operate a bridge. So there is someone that locks your funds on chain A and then releases funds on chain B, and often it's a multi-sig approach. In IBC, it's kind of different. So IBC is the inter-blockchain communication, and it's a protocol. So you may not think of IBC like as an actual bridge, but more also as kind of a transfer protocol like TCP. So we also have these handshakes like, do you want to communicate? Yes, I want to communicate. Do you really want to communicate? So we can see these handshakes of channels and packages and also connections. So we need first to establish clients and then channels, and therefore then we have a connection. And the IBC standard, so it's I would say pretty good described on their GitHub. I will share this right now. So let me share this tab. So if you, for example, want to know how it works, then it's under Cosmos IBC, and here you can see a list of clients and then standards. And Gio will later jump into the Aiken validator code, and it's pretty much the same from the structure. So it's also the same names. And if you want to understand what the validators are actually doing without reading the code, then you can also look into the specs. They are pretty good described. So for example, how to open a channel, how can a handshake be done, and what's an order channel, do I need to respect the sequence number? So it's really like TCP, UDP, we need to exchange messages, and therefore we have a relayer. So a relayer that looks on kind of, or runs in a decentralized way. It's not only one relayer. And the relayers are picking up packages that are IBC related and then deliver the packages to the other chains. You can also use the relayer to register a client and to make a connection or a channel. And the clients are so light clients, which means that they solve the issue of not needing to run a full node on both, so on one machine, so that you don't need to run a full node for both blockchains, essentially, to check if the package is valid, because the relayer does not look into the package, it just delivers the package from A to B. And if there's, for example, a message which indicates a locking action on chain A, then there's the question, can I trust this message, and can I then release the funds on chain B? And therefore we have light clients or light client implementations, which kind of are a minimal approach to implement the consensus mechanism of the other chain. So if there is, for example, a communication between a Cosmos based blockchain or a blockchain that has been built with Cosmos SDK and Cardano, then we need to run a Tendermint light client on the Cardano side, because this is then the consensus algorithm of the Cosmos blockchain, and we also need to run a Cardano light client on the Cosmos side. And this is essentially what we are trying to achieve, or what we are trying to build with this project. I will now jump into the code. So let me check. I've also opened this, with GitHub Dev. So if we look in the structure of this repository, I hope you can see it. Maybe I can just share it here for a high-level overview. So if you look into the structure of this repository, then you can see that we have here a relayer. This relayer is not 1%, or not even, I won't say not even 5% written by our own. It's a fork of the Cosmos relayer. So we forked the Cosmos relayer. There's also a Rust-based implementation called Hermes. We decided to go with the Go relayer of the Interchain Foundation, and here we had to add the Cardano specific stuff to pick up the packages and deliver them. We also had to implement the Cardano Lite client, which is part of the Cardano repository. And there we have an on-chain code, which I think Gio will cover when I pass over to him. And like I said, here you can look into client. You will see the Tendermint client. You can look into core, and you can see the different standards, and it's essentially the same. So it's matching the specs that I showed you. And we have the off-chain code, which is mainly used currently for deploying. Maybe we can rename this, because off-chain sounds like it also does the transaction building. It's currently more or less used to deploy the contracts. And then we have the gateway, which is the actual code which contains the actual code to build the transactions, for example, for minting channels, minting connections, and invoke the validation logic. The relayer, like I said, is not looking into the packages. So the relayer is just delivering the packages from A to B. And then the on-chain code implementing the light client is used to validate and then execute, for example, also business logic on top of the packages. We have a docs repository, which also contains some high-level overviews of the use cases. And then we have Aiken type conversions. In the future, it would be nice to use the blueprint feature instead. We have a tool, or we wrote a tool which is called Caribic. And this is a Rust tool, a command line interface to make it possible to just, with 2 lines of code, to run the run the network, so local Cardano network, and then also to spin up the bridge-related components. Then we have so let me check if I can switch back to this one. So if I start sharing or not sharing a screen, which I'm talking about, because it's sometimes confusing to share the tabs, please directly stop me, and then I will share the correct tab. So you can use Caribic if you just do, for example, network up. In the future, we want to replace this currently local Cardano network, which is under chains Cardano, so the configuration files, with just an interface to a Cardano network. And we want to, for local development, switch to Yassi DevKit. Satya did an introduction or gave an introduction to Yassi DevKit in the, I think, the office hour in January, end of January. You can find it on the community YouTube channel, and it allows you to easily spin up and tear down a local Cardano network pretty quickly, and then run, for example, also tests. And it brings, and this is the interesting part also for the IBC project, it brings the ability to have Yassi Store running locally, which has a BlockFrost compatible API, and the cool thing is that we could then just have a configuration file for the bridge pointing to a Cardano network, so that also the jump from a local devnet to the test nets or to the mainnet would be much easier. Currently, there is this split between network up, so which brings up the network and Mithril, and then also bridge up, which then deploys the contracts and starts the relayer and gateway. When we started with this project, we started with a vendor called Smart OC. These guys are really smart, so they picked up the Cardano knowledge and also the Aiken knowledge pretty quickly. They passed over the project to us at the end of last year, and they more or less also discovered when we started that we cannot just trust the single stake pool operator, because so when we started, we wrote the Cardano Lite client. In the meantime, we switched to the Mithril Lite client. So when we run on the Cardano Lite client, the issue is that the IBC protocol assumes that multiple parties would sign the block for correctness, and in Cardano, usually the block producer is signing the block, and then obviously the next block is then also having the information of the previous block. But if just the stake pool operator, for example, would run a relayer and would present the package to the relayer and then sign it correctly, but it contains, for example, a transaction, so it's never made it to the chain, to the actual chain, but they are signing the package correctly, and then they're delivering this with the malicious transaction, locking thousands of ADA, and they want to have an honest cooperation on the other blockchain of this wrapped ADA, for example. Then this would be possible, as only the block producer is currently signing the block. With Mithril, we have this stake-based evidence, so that's why we decided to switch to the Mithril Lite client. So Mithril is also spinning up if you run network up, and it more or less takes some time to start, and then once the mutable files are available, then it gives you the certainty of the correctness of the block. So I think that's it, just as a high-level overview to the repository from my side. And now I would pass over to Gio.
Right. So, hi everyone. This is Giovanni, and welcome to the second half of the presentation, where we're going to be seeing how to not write Aiken code. And so the first step is just to give a quick overview of the structure of the validators for the IBC bridge. The project is always the same, Cardano IBC Incubator, and there is, as Fabian mentioned just a couple of minutes back, the on-chain folder, which is an Aiken project. Aiken is one of the most popular, if not the most popular, programming language for writing smart contracts on Cardano. The website is aiken.lang.org. It has a standard library here. As I invite you to take a look, and there is a nice set of documentation that is going to get you up and running very quickly. But going back to the project, there are about 20 validators for the IBC bridge that have been over the time refactored and split between the production code, for instance minting client has its own production module and test module with tests inside. These were all packed up together, but now have been separated. So you can test components in isolation. The validators are split into the spending channel that are about 10 or a little bit more. These are the validators that are responsible for managing the exchange of messages on chain, while the other one is for setting up the channel, the port, the different other resources required by the IBC itself. There is also a generic lib module that is split into multiple components. In particular, core has the implementation of all the data structures and part of the validations that have been defined into the ICS interchain specification. A module have been named after the identifier of the ICS. So you should find, I don't want to say one-to-one mapping between the interchain specs and Cardano, but that should be close enough. I will not go into too much details because this is, it gets really complicated really quickly. What I want to focus today instead is on costs, especially when it comes to on-chain resources costs. As some of you may not be familiar with, on Cardano, when we execute smart contracts, there are two resources called the CPU and memory, also known as budget resources, and they have a cost. So depending on how complex and intense, resource intense your smart contract is, you will have to pay a certain amount of fees or Lovelaces. Unfortunately, this is not unbounded because there is a limit per transaction in terms of CPU and memory. So if you write a smart contract that is too complex, it might even just not possible to run because it costs too much. Obviously, if you get to that point, you can break it down and so on and so forth. So this is one of the things that has been followed anyway. But because you're spending for as much as you're paying, it is always worth to try to go as cheap as possible. So today we're going to be saying three things on how what are three easy mistakes that you can make and overspend and potentially introduce bugs into your code. So the first thing, let me see if I can increase a little bit. I don't have a presentation. I should have really done this. Maybe the next round I'm going to make one. But the first thing is, if available, use natively available code and just don't write your own implementation. So if you're trying to be smart, just check if the clever guy in the Aiken team have done this already. In this specific case that we're going to be seeing very soon, the functions that I'm going to be discussing were available into the standard library yet. Were only introduced in a following version of the library. So I tested them and I replaced the code. But in general, if you're writing something and it feels like someone should have already done that, just please check if someone has already done that, because chances are that has been done, is written, is more performant and also less bug prone. In fact, less code means less bugs and less maintenance. That's good for the developer as well. It means that you have to maintain less code. And the second thing is that if it is native code offered by the standard library, chances are it's safer and more optimized, and more efficient. The second thing we're going to be seeing is an Aiken specific thing, that is the function expect versus use of logical operators like and ors when executing validations. And the last thing is a couple of gotchas about testing content of lists. But without further ado, let's start with the first test, the first optimization. So the SmartOC guys, and they were very smart, they needed to convert integers into hex representation, into byte representation of integers as well. So this function wasn't available back in the days. Wasn't available back in the days, so they had to implement their own function. So there is a bits Aiken where there is this put uint64 let's just glance over the fact that there was a tiny bug that has been fixed anyway over the time. But let's see also at the performance of this module. So whenever you're replacing code, the first thing that I always would recommend is to write tests to prove how things are working before you make the change, and then write a test to ensure that the result after you make the change is still the same. Unfortunately, because I'm decommissioning code, I've checked out a previous version of the project that I've modified just for this presentation. So the first thing I'm doing actually, this is in the second half, native versus custom functional test. So I've called exactly the same function with the same parameters, and I'm testing that everything is fine. So what I'm going to be doing is I'm going to be calling the tests for the bits tests. That is like this, utils expect, that should be it. Let's go up here. No, sorry, that's the wrong tests. This is bits test. There we go, that's the one. Is it spend? Let's do them all. So in the bottom part, you can see that we are testing the functional one, and they are all passing. So this is, for instance, put uint64 succeed one is exactly this one. All the tests they have a name, and you can see that they are all passing. So it is proven that the custom code that was written works exactly the same as the code I'm replacing it with. Right now, let's see if by any chance the new code that I'm introducing is actually more performant as well. So as you can see, I've prefixed all the tests with spend. Aiken has a nice feature that I can execute tests within a module, but also prepend filter by the name of the test. So I've put spend, and now I'm only going to see the spend filter. So let's see the difference. This is the uint64 is the custom version. And you can see that it's 7 times more expensive in terms of memory and almost twice as much expensive in terms of CPU. So these feature functions, they were called over and over again when validating a message. So you can see like the amount of savings we're running this test. Let's go into the next one. There is some validation here. As I mentioned earlier on, is the expect versus and or. There are some validators who use expect quite a lot when. So in Cardano, when you're validating something, usually you have like a list of Boolean conditions that have to resolve to true. So is if this and this blah 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 at the end must be true. Expect is a way of testing this thing as well. But it's a little bit different. So I'll explain now. In this case, you can see that there is simply a verification expect that this thing, they are different. So there is no need to go for expect. This could have been just a simple and all these conditions, right? Instead of making expect. So I just wrote a little class to see some tests to see how this thing works. So we have a simple function that is returning a simple sum, a container class with the value inside, and we can see the difference of how to implement this test. Now, these two tests are literally equivalent in terms of costs, because when the expect works really well is when we are destructuring. I know I'm going a little bit into technical details, but this is more for developers. So whenever you have like an optional and you want to test what's contained, you have to destructure. So you have to inspect what's inside the object, and expect works really well. And apparently it's also very efficient as well. So these two notations are literally equivalent. Where the differences start to be obviously very different is when you're testing like a simple condition. So you have some condition that is just like a true or false, and we are testing with expect and with sum. The costs are better. Now, where is it? So if we are using the pattern match in the first test, they're exactly the same costs. So test sum expect, and one after, they have exactly the same cost. while there is a big difference between those two guys. If you're just testing Boolean, expect is dramatically more expensive, 5 times in terms of memory and 22 times in terms of CPU. And now the last thing about lists, again, this is getting a little bit more technically complicated, but when we are testing with lists, IBC, the contracts, they have a lot of work, a lot of conditions based on lists. When we are testing for list length, they were doing list.length. When they were checking for emptiness, they were doing if the size is equals to 0. So this is actually a really expensive operation, because in order to know the length, the compiler needs to go through, the runtime needs to go through the full length of the list. But actually, the length of, if a list is empty, is a statically available operation. In fact, there is a method that is list is empty on an empty list, and this is really cheap. And there is another trick for when the list contains only one, you can use destructuring. That is really a cheap operation. So let's see in terms of costs how this performs. So in case of list empty, if you use just is empty, is a third of the memory and a third, give or take, the CPU. Pattern matching with just one operator is a clear winner. In terms of CPU, is like, again, 50% of the costs. In the list, in case you need to check the list, you can see that the cost in terms of CPU and memory grows very, very quickly. I'll stop here. And the result of these improvements, considering that this code was executed again and again across the 20 contracts, allowed us to basically take the costs of running this contract to a point whereby if we had traces enabled, some of those contracts they wouldn't deploy because they were too big. So with just like a few examples, sorry, they wouldn't run because they were too big. So by just applying these few things, we had a dramatically reduction in costs.
You can also check out the repository, and then we're currently working on 3 use cases or 3 demos. The first one is sending a demo message from Cosmos to Cardano. Sebastian prepared the vessel demo use case, so there are different chips traveling around, and then there's a simulation where they send positions and asking for a harbor, and this against the Cosmos app chain, so it's scaffolded with Ignite. And then the data becomes collected, consolidated, and transmitted. And when it's transmitted, then the relayer will pick it up. So it's then an IBC message and hopefully delivered to Cardano. And then we can run some business logic on top of it. The second demo, which is currently under construction, is the transferring tokens from Cardano to Cosmos and vice versa. And we have the cross-chain swap. Today, I want to show you the demo of sending messages from A to B. So I will now share my my console. So, like I said, it's actually just running a network up, and then it takes a while until the local Cardano network is running and Mithra is running, and then it's bridge up. And then we will also have the relayer and gateway running. So now I did a Docker PS just to grab also the container IDs. I can quickly show you how this looks like in the relayer container. So once the relayer started, it directly wanted to create the connection or make the connection, and therefore it started to create calling the open client or create client transaction, and then it's listening to the other chain, it's picking up, there's a client created, you need to update the client and so on. So it essentially kind of ping pong starts, and then at the end it ends up with a message, should be here, so that there is successfully created new channel, and this for both chains actually, so Cardano and for the Vessel Oracle, which got the chain ID 0. And this is important. So we will now remember the chain ID 0, and I will go back to the to my bash where I have where I run the Caribic code. Let me resize the window. Probably it's then should be better now. So I will now jump into. Thank you, Sebastian. I will now check into run into jump into the container. That's what I wanted to say. So it's the Summit demo E1C, and then there is a repository. It's I can share it also here in the call. It's this one, and yeah, it has some documentation in it. So the steps that I'm now doing are kind of part of the README. So I go into the data source folder, just running a quick go mod tidy before, and then we will simulate the kind of position transmission from the vessels to this local Cosmos chain, which is running in this container. So we need go run and then report minus simulate. Now it takes a while. In the meantime, I will open in Docker Desktop the container because I need to switch again into the container once we consolidated the data. In the Docker container, so the main process is running the Cosmos chain, and the and now I'm in that container and issuing also the these commands to simulate the transmission of positions. And now I'm running go consolidate, and this now also removes outliers and like it said, consolidates the data. So let me present now again the Docker Hub. So if I now jump up, then we can see that here was a transaction with the consolidated data. So this has been called, and there's a log somewhere which indicates that the data has been consolidated and consolidated data report generated, and here we have a timestamp. So now we need both to issue the last command that I will show you. It's the timestamp that we need, and it's also the channel ID. So let's jump back into our bash console, and now it's go run transmit, and we have the channel ID channel 0, and we have the timestamp, and it's 173.952 and 8. So once we run this command, okay, it's successful. Now I start presenting Docker stuff again. So if we now look into the relayer, then we can see that there is a successful transaction issued on Ogmios, and the message receive packet has been picked up, and now it's actually on us to handle the business logic in the gateway. Currently, the idea is just to make this data part of the Cardano blockchain so that we can use it as an oracle, for example, in a datum. But there's also kind of, for the other use cases, the package structure would be different, for example, for the token transmission. So we have then a voucher issuing or unescrow, and the same is actually true for the interchain swap. Yeah, that's it actually from my side.